Hi everyone, welcome to OneClass live stream. This is Chang, C-H-A-N-G, and today we're going to cover some of the more popular asked math problems on OneClass. So let us get started. Alright, let's see what is our first question. So our first question today is asking us, what do brackets mean in math? So for our first question, we're talking about brackets. Off the top of my head, there are two main ways that brackets are used. The first way is just to, let's just say way number one, is to group terms together. Group terms together for the order of operation. Group terms together for the order of operation. For instance, we might want to group. So for instance, if you have an expression that looks like 3 divided by 6 multiplied by 2, in those cases, if you're following the order of operation, you would try to calculate 3 divided by 6 over here. However, if you put the brackets around the 6 times 2, then you have to calculate the expression that are in the brackets. So in this case, you actually have to calculate 6 times 2 first, and then 3 divided by 12, which is the result of 6 times 2. So this is the first use of the brackets. And for this use, you actually have 3 main types of brackets. You have 3 main types. 3 main types, and they are the round brackets, the square brackets, and the curly brackets. Also, I'm kind of assuming that the brackets are talking about round brackets in general, because there are a lot of uses of brackets in math, but I'm just going to talk about the two of the most common ones. So all those brackets, they actually just have the same function, which is grouping together terms for the order of operation, except for example, when you have a really complicated expression. So for example, if the 3 times 2 divided by 6 minus 1 multiplied by 7 plus 19, in those cases, if you're just using the round brackets everywhere, so like if you're only using round brackets everywhere, it might seem a little messy. This is where the square brackets come in. So basically, as a kind of like a proper form, the round brackets should be the innermost brackets, and the square brackets should be the next up, and then it's the curly brackets. So basically, they're just saying that in this case, you're just trying to calculate the operations in the innermost brackets, and then you go out 1 layer, so to the next layer of brackets, and then you go out to the next layer, and then you calculate it based on the rule of the order of operation. So in this case, you would go to the innermost brackets, which is 7 plus 19, and this is 26. Then you go up to the next level of brackets, which is 1 times 26, which is still 26. And then you go up to the next layer of brackets, and it's 2 minus 26, which is negative 24, and you just calculate it normally. So yeah, this is kind of the first use of the brackets. And the second one of the really common use of brackets is just you use brackets instead of multiplication sign. Use brackets instead of so sometimes you would have 3 times 7 times 5x minus 2 times 18x plus 3. So sometimes instead of writing the expressions like this, we would just eliminate the multiplication sign, because a lot of multiplication sign grouped together might look a little messy. It's not as clean as where you just use the brackets notation instead of multiplication sign, and you just write the expression like so. This looks much cleaner. The expression in blue looks much cleaner than the expression in black up there. So yes, another really common use of brackets in mathematics is that people or mathematicians, or just people who does mathematics, they use brackets instead of the multiplication sign for like a more clean notation. So yes, these are kind of the two of the main ways of using brackets that we're going to cover. Let's look at the sample solution over here. Yes, they just only mentioned the first use, but I guess this is definitely a valid use. So I'll just say the solution is correct. Might be better to add one or two more uses, such as the usage of brackets instead of multiplication sign, etc. Cool. So this is just the comment I'm going to give, and I'll say solution is correct because it wasn't wrong to just mention that brackets is used to group together the order of operation of expressions. Okay, so this is our first question. Now let's look at our second question over here. Our second question asks us, how would we calculate the cosine of 3 pi over 2? The answer is quite simple. We just use the unit circle. So here we have a unit circle. Let's draw a unit circle. And here we have the x-axis and the y-axis. We know that angles in the unit circle starts from over here. And we know that this is pi over 2, 90 degrees. This is pi, which is 100 degrees. And this is another 90 degrees, which is 3 pi over 2. So the angle over here is 3 pi over 2. And the angle would be right over here. So this is actually a special case because this is on the axis. We also know that the coordinates of the x and y coordinates on these axes, it's 0, -1. This is the xy coordinates on this specific point over here because it's the unit circle, which means the radius is just 1. Actually, let's just draw the circle here. I'm really bad at drawing circle, but basically the radius of this circle is 1, and it's a really regular circle, although my drawing might not be as regular as I like it to be. So yes, you know what, let's just leave out all the other coordinates as well. This is 0, or I'm sorry, this is 1, 0, where x is 1 and y is 0. You know what, let's put, so this is x, and this is 1, 0. Over here, it is 0, 1. Over here, it is -1, 0. Cool. So we also know that in the unit circle, the value of x's is actually the same as the values of the cosines. Since the value of x's over here on the unit circle is 0, this is 0 at 3 pi over 2 radians. We know that the value of cosine is also 0 at 3 pi over 2 radians. So the value of cosine of 3 pi over 2 is just equals to 0. And this is how we arrive at our answer based on our information about the unit circle. Obviously, you can just also memorize the basic angles, but personally, I think it's much easier to use the unit circle to quickly think about it, and to also to use special triangles to quickly think about it for the cases of other more other common angles. But of course, you can just memorize it as well. Just personally, I don't like memorization as much as reason through my way. Okay, so this is how we found the cosine of 3 pi over 2. Let's look at the sample solution here. Yes, the sample solution also said that we should consider the geometric circle, assuming they meant the unit circle, because it is the special circle. And here they also had all the angles all the values of commonly seen angles listed over here. Is quite comprehensive actually. But again, I don't like memorizing this whole table. And they have like kind of a pattern, so using special triangles and using like special triangles and the unit circle to arrive at the answers, it's so much easier than memorizing this entire table. But this solution is correct, so let's just say the solution is correct. Nicely done. Now let's move on to our third problem. Alrighty, our third problem asks us, how should we find the inverse of y equals ex? There are actually two main ways of doing it. So it's asking us to find the inverse of y equals e to the power of x. The first way is just, let's say, solution 1. The first way is obviously just directly saying that the inverse of y equals ex is y equals ln of x. Why? Because we know that y equals ex, because y equals ex, it's the exponential function, and the inverse, so the inverse of the exponential function, it's the ln function. Let's just say it's the ln function. So we can just directly say that the inverse, or y to the power of -1, the inverse of y to the power of y equals e to the power of x, it's ln of x. This is our solution number 1, written like that. But solution number 2 might be, you might prefer solution number 2 where you actually derive the inverse of y equals ex. So let's follow the steps of finding the inverse function. First step of finding the inverse function is that we switch the order of x's and y's in our expression, or we just swap x and y in our original equation. So right here we have y equals e to the power of x. So now we have x equals to e to the power of y. Then we try to get y alone on its own. In order to do so in this specific case, we would want to take the line of both sides of the equation so that the equality is preserved. So ln of x is just ln of x. There isn't really much we can do to simplify it. But based on the rule of logarithmics, ln of e to the power of y can be simplified as y ln of e, y times ln of e. Also, we know that ln of e is actually 1 because, again, ln of e is actually a special type of logarithmics with base e, and we know that log of e is just 1. So this case, ln of e is actually equals to 1. So we have ln of x equals to y times ln of e, which is 1. So we have y equals ln of x. Perfect. And now we're done. Our third step, or last step for proper form, is just we write we switch y with y to the power of -1, which is a symbol for inverse. So here we completed our solution, and we know for the function y equals e to the power of x, its inverse y to the power of -1 is ln of x. Perfect. This is how we solve this problem. Now let's look at our sample solution here and see what did they do. They adopted approach number 2, and basically they did the same thing as us, except they used a different notation for y to the power of -1. So yeah, let's just say the solution is correct. Solution is correct. Excellent job. Nice. Now let's move on to our fourth problem for today. Let's see what the fourth problem is. Okay, our fourth problem actually asks us to find the secant of pi over 2. So let's just write our problem number 4 here, and it asks us to find the secant of pi half. Alright, so So we know that the secant function is actually equals to 1 over the cos of an angle. So the secant of an angle is equals to 1 over the cos of an angle, and secant of pi over 2 is equals to 1 over the cos of pi over 2. Next up, we use our unit circle to check what the value of cosine of pi over 2 is. Again, we have a circle over here, x, y, and at pi over 2, actually, let's just draw a circle a little bit nicer, because the center of the circle is supposedly on the origin, and it just doesn't seem like it. Cool. I'm not sure if this circle is better, but I think there is a little of improvement. Now, let's look at the angle pi over 2. So the angle pi over 2 radians is 90 degrees, which is, which is right here on the y-axis. We know that the value at the value over here is actually 0, 1. And we know that on the unit circle, the cosine values are the x values and the sine values are the y values. So we know over here, the cosine of pi over 2 is actually equals to 0. So secant of pi over 2 is actually 1 equals 0, which doesn't have a result, because 1 over 0 is not defined, which is basically just a fancy way saying that 1 over 0 it's just undefined. It's undefined. So like it's not like you can't get an actual numerical value out of it. So you're just saying that it is undefined. This is like a mathematical term you use in this case. So the answer of secant of pi over 2 is just undefined, and that is your exact value of secant of pi over 2. That is undefined because it doesn't you don't have this exact value. All right, so this is our solution, and let me show you something else quickly. So let's draw, or I guess let's use our graphic calculator. Let's draw the secant of pi over 2, or I guess let's draw the secant of x. And I guess I can't change the color. Nope, can't. Okay, so this is our secant function over here. This is what it looks like. It basically looks like a parabola. It looks like a lot of positive and negative parabolas spread out on the plane. This is what the secant of x, the function of the secant of x looks like. Now let's find where x equals to pi over 2 is. Pi over 2. All right, so the line in red is x equals to pi over 2. We know that over here on the secant function, when x equals to pi over 2, the value of y actually doesn't exist. Because notice how right over here, the secant function, which is the black line, is approaching the red line, which is pi over 2, infinitely, but it never really reaches the red line. So like you can see from here that it just try to approach or try to reach to pi over 2 and never reaches it. That's why the value of secant of pi over 2, which is the y value of the function of secant of x at pi over 2, it doesn't have an actual value. And because of the vertical line here, it's called an asymptote. Because of the existence of vertical line here, we call this undefined, meaning it's trying to reach it but never actually gets there. Similarly, from the other side of the red line of pi over 2, again the secant function tries to approach the line of pi over 2, or try to approach the value of pi over 2, but it never gets there. So yeah, again, the value of secant of pi over 2, it is undefined in this case. And that's how we write out the answer. So yeah, this is what I'm going to cover for this question. And let's look at the sample solution now. Yes, they also mentioned that it is undefined, and they also drew the secant function. They didn't put a line here for the value of pi over 2 for it to be more clear, but I guess it's all right. So yeah, let's just say, great job. The solution is correct. The solution is correct. Perfect. Now let's move on to our next problem. Okay, our next question asks us, how do we evaluate arctan of negative root 3? So let's scroll down. This is another trick question, and it's asking us to find the value of arctangent of negative root 3. So we know that the tangent of an angle is equals to a value. So the arctangent of a value is equals to an angle. And now I just need to find what this angle is. Now, we look at the number root 3, and thinking back to our special triangles, we know one of the triangles has one of its sides as root 3. So obviously we're going to obviously that angle exists in that special triangle, and we're going to try to see which specific angle it is by drawing the special triangle. So we know here it is 30 degrees, and here it is 60 degrees. So let's see. The root 3 side is over here, and we know the tangent function is equals to opposite over adjacent. As in the tangent of an angle, the value of the tangent of an angle is equals to the opposite side to the angle over the adjacent side to the angle. So in this case, which angle's opposite side over adjacent side had something to do with root 3? Obviously, it's the angle 30 degrees because the opposite side, it's actually the angle 60 degrees because the opposite side to 60 degrees is root 3. This is the opposite. And the adjacent side of 60 degrees is 1. This is the adjacent. So tan of the angle 60 degrees is equals to root 3. However, we're not looking at the arctangent of negative root 3. We're looking at, okay, let's just write down here. The arctangent of root 3 is equals to 60 degrees. But again, we're not looking at the arctangent of root 3. We're looking at the arctangent of negative root 3. So we need the help of another really handy tool, which is our unit circle red over here. We have our x's and we have our y's. So we know that the 60 degrees angle over here is root 3. So, and right here, both x and the y's are positive, so our root 3 is positive. But over here, on the fourth quadrant, in this section, the x is positive and the y is negative. So for the angle negative 60 degrees, our root 3 would be negative. You might be thinking, what about this quadrant number 2? The angle would also be negative, or the value of the tangent function would also be negative for the angle over here. So how about for the angle 120 degrees? You are indeed correct. That angle would also work. However, you need to know that the value of arctangent is actually between, or I guess I'll just do it in radians mode. It's actually the angle of 90 degrees, or sorry, the value of arctan is actually between negative 90 degrees. I like to say pi over 2 or negative pi over 2, but it's fine. I'll do degrees over here. So the value of arctangent function is actually between negative 90 degrees to 90 degrees. Why? Because we need to define the arctangent function as the inverse of the tangent function. And the tangent function technically doesn't have an inverse because it doesn't pass the horizontal line test. So what we did is that we restricted the domain of the tangent function. So the domain of the tangent function is restricted to negative 90 degrees and 90 degrees. That way, the tangent function could actually have an inverse, which is our arctangent functions over here. So since the domain of the tangent function is restricted, the range of the arctangent function is also restricted to negative 90 degrees and 90 degrees. And that's why only the degree 60 works and 120 doesn't work, because 120 is larger than 90, and arctangent of a function which is outside of the range of the arctangent of a function, the arctangent function. Cool. So we have our answer over here. The arctangent of or I'm sorry, I actually didn't write it. So the arctangent of the arctan of negative root 3 is our degree right over here, our negative 60 degrees. So the arctangent of negative root 3 is negative 60 degrees. And let's just put our answer in a box over here. Nice. So this is our solution for this problem. Now, let's look at the sample solution over here. Yes, they basically said the same thing, except they didn't use unit circle, but instead they used the identities where tan of negative of an angle is equal to negative tan of an angle. But in my opinion, this is a little bit confusing because there are a lot of functions for tan, secant, cosine, sine. There are like a lot of identities to remember, and if you mess it up for once, for remembering this sign wrong, then you're kind of like, you know, in a little bit of trouble. So yeah, their solution is correct. They use negative pi over 3, which is this. They use negative pi over 3 radians, which is the same as negative 60 degrees. Okay, so let's just say the solution is correct. Great job. Alrighty, here's our next problem, and it's asking us what is the square root of 105. Okay, so when we see a problem like this, there are 3 approaches that you should take. The first, you should try prime factorization. Try prime factorization to see if you can solve the problem this way. Unless you have a calculator on hand, then you might want to try something else. But first, let's try to prime factorization. Prime factorization is basically writing a number as the product of its prime factors. So let's see what's the prime factor of 105. Obviously, 105 is a number that ends in 5, and we know that any number ending in 0 or 5 has 5 as one of its factors. So we can use 5 over here, and we know that 105 can be written as 5 times 21. Then we have 21, and we know that the sum of the digits of 21, so 2 plus 1 in this case, is 3. And 3 is a multiple of 3, so we know that 21 is also divisible by 3. So we have 21 is 3 times 7. Now we can write 105 as 5 times 3 times 7. We also know that 5, 3, 7, they're all prime numbers. So our process of prime factorization is finished at this point. However, we notice that the square root of 105 cannot be further simplified. Cannot be further simplified. Because there isn't a pair of factors for the square root of 105, so we can't further simplify the square root of 105. So the first way is like, usually over here you can just say what is the square root of 105? You can just say the square root of 105 is just the square root of 105. It wasn't too much of an interesting answer, but as long as you show that you've done prime factorization and saying that the root of 105 cannot be further simplified, and then it's just the square root of 105, it's a completely perfect answer. Now let's look at our second way. So if you're asking the square root of 105, you could also just use calculators to do it. Use calculators to find the exact value of the square root of 105. So let's just do it over here. The square root of 105. It is approximately 10.247. This is just approximation. It's not the exact value of the square root of 105 because this number is irrational. So yeah, this is the square root of 105 using a calculator. So let's just say using calculator. Again, there's a third way where you can find the square root of 105 by hand. hand. So like you can, for example, perhaps you can use linear approximation. So you can have a function y equals the square root of x, and you can use x equals 100 to approximate, and you use a equals 105. So you can, I'm not going to do the entire process, but basically you can use linear approximation to approximate the value of the square root of 105 by hand. It is actually quite accurate, usually in most cases. So yes, you can also use linear approximation to approximate the value of the square root of 105. There's also another way where you can use long division. Use long division to approximate the square root of 105. So use long division to approximate. Again, I'm not going to go too much detail into the linear approximation and long division method. Usually, for the level that actually asks those kind of problems, using prime factorization or using a calculator, it should be sufficient. Unless they specifically explicitly told you that you should use linear approximation to find the value of the square root of 105, giving them an answer arrived by calculator and told them you use a calculator to find the answer, or just use prime factorization are completely acceptable in most cases. Cool, now let's look at their simple solution. They just tried to use a prime factorization and they said, oh, you can't, so they just use a calculator, which is our first and second method, and also the more common methods. So yeah, let's just say the solution is good. The solution is good. Nice. Cool. Okay, we're at 2:47. So actually, couple minutes over our live stream today, but it's alright. So let me just switch back to the camera. So again, thank you for coming to our live stream today. This is all we're going to cover. If you like the popular math problems asked online OneClass and you want them explained, please come to our future live streams. If you would like, you can click subscribe button down below. This will give you a notification of our future live stream. So I hope you enjoyed it and hope that you have an excellent day. I'll see you next time.